to either order specimens from us, or you can make your own specimen. And I showed you the diagram in the book.
There's a aluminium or what?
Aluminium, steel, or brass. Three types. Three
Yeah.
types. And I'm pretty sure you've got a lathe machine here where you can do that.
Yes.
The drawing for that is in the manual, okay? Now the reason they are shaped like that, if they were not shaped like that, they would be like this, okay? But this would take many days, weeks, even months to fail. So we deliberately put a shoulder, and that increases the cycles to failure. Otherwise you'll be stood here for maybe 6 months, and that would be a complete waste of time, okay? So that's the reason they are shaped like that, okay? So the object of this is to look at an SN curve. So that's cycles, okay? That's the cycles against the stress, basically. Stress against cycles. And that's all we are doing here, okay? You're going to produce a graph, an SN curve, looking at different loads on the material. And each time you fit one of these, you will break it, you will write down, or use the software to record how many revolutions it took to fail, and also you will calculate this value here, which is the maximum bending stress, which is MPa. That's the only two values that you are interested in, okay? So if you look down here, forget the computer now, if you look down, you'll see there are 3 different readouts. You have load, rate, rate in hertz, and count. So the load is the amount of load that you are applying to the specimen. That's the amount of load. And the load is varied by moving this across. And as you go further left, so the load will decrease, and further right, it will increase, because the load is closer to this vertical arm. Okay? The rate, now normally you use RPM as the speed. Normally. However, with rotating fatigue, you use frequency in hertz. Okay? And the rate, hertz, is the number of cycles per second. Now one cycle is 1 revolution of the specimen, but you have a tension and a compression. Okay, so it's going to look like a sine wave. Okay, let me just show you. So this is a bit different to what you're normally used to. It's unique to rotating fatigue, because it's a German professor, maybe 200 years ago, that discovered this. Okay. Let me show you in the manual what 1 cycle is. Okay, so if you can imagine, every time this turns, it's going to bend, and it's going to compress and tension. Compress, tension in 1 cycle. Okay? And that is shown here. Tension and compression. Tension and compression. That's why we use frequency and not RPM. Okay? It's what's done in the industry. Okay? So you have load, speed, which is hertz, and cycle rate, which is the number of revolutions until it breaks. So this will record how many revolutions that turns. And when it breaks, there's a switch that stops the machine immediately, and you will be able to record the data from your readout here. And then from that data, you and your students can then calculate, using the theory which your professors and yourself you will be comfortable with. You calculate the stress, and you will then calculate the bending moment, which is the mass, which is force times the length of the specimen. Okay, and then you will calculate the MPA from that formula here. So if you do not use the software, this is the formula. Okay, so length is 28, F is the force, 50 is the load, okay, 32 is, I think that's the factor, and then pi times the diameter, and that will give you the MPA. So I'm not a mechanical engineer, but even I understand this, okay? I'm more electrical and engines, you know?
Yeah. How do you measure it?
You measure it on the display here. You have three values: force, which is newtons; hertz, which is the rotation, speed, and then you have the number of revolutions, which is cycle count. So it's three displays. And with those values, you can introduce into this formula and calculate the MPA. Okay?
The load is displayed.
Yeah. An MPA is the maximum bending stress. Maximum bending stress. So a typical lab session, you will break 5 of these, because the objectives are you want to build what's called an SN curve, stress against the number of cycles. Okay, and that is shown. Again, the manual also explains the SN curve and what you're trying to achieve. So this is an SN curve. So there's 1, 2, 3, 4, 5 readings of specimens. So 5 specimens have been broken at different loads. So that's the highest load, where it is that end, and then you move it 2, 3, 4, 5. Now we don't tell you where to move it. It doesn't. That's not too important. Okay. We recommend that you, I think, move it every 5 steps. So 1, 2, 3, 4, 5. I think that's what we recommend. Let me just check that, okay, before, make sure I'm not telling you